page 29. Pure, White and Deadly, by John Yudkin, 1972. Chapter 4. Where Sugar Comes From. The sugar with which this book is concerned is what most people simply call a sugar. It is sometimes called a cane sugar, although in fact about 1/3 of the sugar consumed comes from beet. Chemists call it sucrose. In this chapter we discuss where it comes from and how it is prepared. We shall then look at the effects it can have in the body. Nearly 99% of the sugar we consume is made from sugar cane or sugar beet. The other 1% comes from such sources as the maple in New England and Canada, the palm in India, and millet in the southern United States. Quite tiny quantities are also sometimes made from grapes, carob beans or dates. In spite of popular belief, there is no difference in taste or any other ordinarily recognizable property in refined sugar isolated from the cane or the beet. Each contains more than 99.9% pure sucrose. Only the most sensitive analytical techniques can detect differences due to the presence of minute quantities of substances characteristic of one or the other. 4.1. Cane sugar. Like the cereals, the sugar cane, Saccharomyces, belongs to the grass family. Its original home was apparently somewhere in Asia, possibly India. It has been cultivated for 2,500 years and its wild ancestor is no longer known. It now grows mostly in plantations in many parts of the world. Cultivation probably began in China and India before 500 BC. In 325 BC the soldiers of Alexander the Great in India spoke of a honey not from bees. Cultivation spread westwards, reaching Persia, by AD 500, Egypt, 640, Sicily and Cyprus, 700, Spain, 755, and later Madeira, the Canary Islands, North America, Mexico and by the beginning of the 16th century the Caribbean. The cane requires a warm climate, rainfall of at least 60 inches a year or adequate irrigation, and plenty of fertilizer. The countries producing the greatest quantities of cane sugar are shown in the table. The history of sugar cane cultivation in the Caribbean can hardly be a source of pride to humanity. The Europeans from Portugal, Spain, Holland and Britain first took the sugar cane to the West Indies, rapidly overcame the indigenous population of Caribs and then proceeded virtually to exterminate them. They solved the problem of providing the labor force needed in the sugar plantations by bringing slaves from Africa. Thus was established the infamous triangular trade. Rifles, cloth and other goods were shipped to the west coast of Africa, where they were given to the African chiefs in exchange for slaves captured in the interior. These were herded into the holds of ships and taken to the Caribbean islands such as Jamaica and St. Kitts. Those that survived the horrendous conditions of the journey, often less than half were then used on the plantations. The raw sugar from the islands was shipped back to Europe, especially to England for refining, thus completing the triangle. The appalling conditions in the ships and the plantations caused so many deaths that the supply of slaves had to be constantly replenished by fresh imports from West Africa. In the earliest days, cane sugar was simply the dry juice that had been pressed from the cane. A similar product known as agar or jaggery is still made in India. Most sugar used nowadays, however, is refined white sugar. Sugar from the cane is usually produced in two stages: at the extraction of raw sugar, and then the refining of this to white sugar. The sugar cane is cut by hand or, increasingly, by machine. The tops and leaves are removed and the canes brought rapidly to the factory. There they are cut, crushed, shredded and passed through roller mills, which press out about 2/3 of the juice. The crushed fiber, known as a bagasse, is sprayed with a little water and passed through another set of roller mills. The quantity of dried bagasse produced is more than enough to provide for the energy needs of the factory. The surplus is sold to local generating stations or for paper manufacture, or mixed with molasses for animal feed. The juice pressed out of the cane is at this stage a turbid grayish liquid containing some 97.5% of the sugar originally present. About 16% of the juice consists of dissolved or suspended solid matter, of which 85 to 90% is sucrose. The juice is now heated to boiling point and lime added. This produces a copious precipitate, which rapidly settles as A-bottoms, leaving clarified juice above. The A-bottoms are spread over the fields as A-mud, acting as a fertilizer. The clarified juices are evaporated, first in open vessels and then in vacuum pans. Eventually the sugar begins to crystallize, becoming a mascuite, a mixture of sugar crystals and syrup. These are separated by spinning in a centrifuge at up to 1,200 revolutions per minute. The result is two products: a raw sugar and cane molasses, or syrup. The molasses are boiled twice more, and the process of crystallization and centrifugation is repeated. After the third boiling there is usually not enough sugar left in the molasses to make it worth trying to extract more as crystals. The final molasses, with whatever sugar it does contain, is used in a variety of ways, for example, to make rum or yeast or cattle food. The raw sugars produced by the three boilings are progressively darker in color. The lightest is called demerara, even though most of it no longer comes from the part of Guyana bearing the name. The second crop of crystals is called light muscovado and the third crop dark muscovado. The next step is for the raw sugars, either separately or mixed together, to be sent to the consuming countries, where they are processed into refined white sugar. The raw sugars are washed and then dissolved, melted, in water, and the solution is decolorized by passing it through columns of charcoal. It is then put into vacuum evaporators and boiled until the concentration of sugar becomes high enough for crystallization to take place. This is started when a small quantity of crystals is thrown into the concentrated syrup, the precise timing determining the size of the new crystals. The contents of the evaporator, a mixture of crystalline sugar and syrup, are now transferred into large centrifuges, each with an inner perforated basket in an outer cylinder. Rotation of the basket results in the syrup being forced through the perforations while the crystals remain behind. If sugar cubes are required, the wet mass is poured into a shallow flat tray which is covered with a lid and passed slowly through a heated chamber. The resulting thin slab of sugar is chopped into cubes by a sort of multiple guillotine. Some cane juice, instead of being evaporated to make raw sugar, may be processed in the plantation factory, producing what is known as a plantation white. This may be done by asulfitation, in which sulfur dioxide is passed into the lime juice so that calcium sulfite is formed. Alternatively, calcium phosphate may be produced in the juice, or both phosphate and sulfite. Rarely, the cane sugar juice is treated by the carbonation process which is routinely used for beet sugar juice. Whichever method is used, the virtually clear, colorless juice is filtered off and dried in evaporators to give plantation white sugar. Page 33.